Hello Year 9. Today we're going to carry on from your surface area practical that you looked at in your e-learning tomorrow. But first I'm going to run through a few things with you just to make sure that the analysis and conclusion section can be done properly. So the first thing we are going to look at is a little recap of surface area. So I'm going to give you a few seconds now to calculate the surface area for this top cube that we have here, the volume. Obviously we've got one piece because there's one piece here, so we can write one piece, and what the total surface area would be. So pause the video for a few seconds, work those out for yourself. Okay, hopefully you should have worked out that the surface area is 10 times 10, 100 times the 6 faces of the cube, so the surface area should be 600 centimeters squared, and the volume should be 10 centimeters times 10 centimeters times 10 centimeters, so should be 1,000 centimeters cubed, and therefore our total surface area, one piece, is still 600 centimeters squared. And that tells us roughly how many particles are exposed for the reactants to collide with. Because obviously, if you have a chemical, you can't collide with the bits in the middle. Okay, you can only collide with the outside surface. So the reactants can only get to those particles on the outside until they react away. And that's why quite often our marble chips get smaller as we do our experiments. Okay, so if we take the same volume and mass of the chemical, but we cut it up. So if we cut it up into our little 1 centimeter by 1 centimeter by 1 centimeters cubed, what would be our surface area, volume, number of pieces, and total surface area now? So again, pause the video for a few seconds, work out our 4 calculations, and then come back to me. Okay, hopefully you've worked out that the surface area is going to be 6 centimeters squared for our little cube, 1 by 1, it's 1 and 6 faces. Our volume is going to be 1 centimeter cubed, 1 times 1 times 1. But our number of pieces, because we've taken the same volume of mass as up here, is going to be 1,000 pieces, because we've got 1,000 centimeters cubed, each one's 1 centimeter cubed, so we should have 1,000 pieces of our chemical, which means our total surface area is now 6 centimeters squared times 1,000, so it is 6,000 centimeters squared, a much 10 times bigger surface area than our big chunk. This means we have far more particles exposed for the reactants to collide with. Okay, so what does this mean for our surface area and how it affects our rate? So you should be able to work out from this, guys, that as surface area increases, the rate of the reaction will increase and the time to react will decrease. Remember what I said about in the exam, checking whether they're asking you to describe the rate or the time, because it's very important that you get the right one when you're talking about it. And as we've talked about before, if the surface area was decreased, if the particles were made bigger, we would swap these two round. The rate of reaction would decrease and the time to react would increase. So why is this? This is because, explain why the rate of reaction changes question. This is because same formula as we use for the temperature one, guys. You need to explain what's happened to the particles and then explain how that impacts our 3 things we had for our board games: our collisions, our orientation, and our energy versus activation energy. Now, with surface area, you are only changing one of these things. So this is only going to be a 2-mark question. Remember temperature, you change both the collisions and the energy versus the activation energy. We're not adding any energy to this one. We're not affecting the orientation. So the only thing we're going to be changing is the collisions. So first thing to describe, what is happening to our particles when we increase the surface area. And this is because more particles are exposed to the reactants. So as we said, because we're making more surface area, there's more particles that can collide with the outside edges, so more reactants can get to the particles. So first mark, more particles exposed to the reactants. Second mark, and you're going to recall this one, it's going to be ingrained in your head forever. So there are more collisions per second. Remember, it's very important that we give it per time, otherwise it will not work. And same as with our decreasing, all you have to do is change one word every time we swap more for less, if the question asks about decreasing. So if the surface area is decreased, the rate of reaction decreases because there are less particles exposed to the reactants, so there are less collisions per second. So guys, you should now, if you've made some notes like you should have done, have enough information to finish off your analysis section and your conclusion section from the worksheet you were looking at yesterday. And hopefully you remember to take some graph paper home, like we said before we left school on Friday. And you will need to upload those graphs and the answers to these questions for me to finish off today. Have a good day.